Hello and welcome to this theory lecture about cloud environments. This is the third theory section of the course Introduction to DevOps. In this lecture we will cover the following topics. First, I will introduce you and give you some background information to cloud computing. Then we will discuss some cloud providers and especially Microsoft Azure. Finally, we are going to talk about cloud environments and web applications. So, for introduction, in order to run and publish software, you need a suitable production environment. The production environment as a term means the setting where the latest working version of the software is run. So you can have it doesn't matter what kind of a software you have, you need to publish it somewhere. And well, usually the production environment is the setting where the customers or the users of your software are able to access your product and software. You can also have other environments like testing or staging environments, but in the context of this course we will only be talking about production environments. So the key thing to understand is that be it any kind of a software, you need some kind of an environment to publish it to your users. There are many ways to set up a production environment for a software. Traditionally, companies and development teams have used their own server computers in order to set up a environment to run the software. For example, in the case of a Java-based software, the development team could have their own server computer, install the Java runtime environment to it, and then run the software there and make the server accessible by the users of the software. There are also ways to buy these dedicated servers, which essentially are server computers that are owned by some other company. Similarly, you will set up the production environment there and make the software accessible to your users. However, now there is a third way to use and configure or use computing resources, and that is the cloud computing. So cloud-based resources mean that the development team uses this cloud provider that is providing all kinds of computing resources like processing power, storage, and networking and things like that. So compared to the traditional ways of publishing the software, the cloud-based resources are more scalable and dynamic, and it is a more modern way to publish software, and we will next talk about cloud computing in more detail. So here is the definition of cloud computing by NIST. They state that cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. So let's stop and think a bit about this sentence. So the words ubiquitous, convenient, and on-demand refer that or mean that the cloud resources are really easily accessible. And they are always accessible over the internet. Most of the cloud providers have this web-based internet portal that can be used to manage the different cloud resources. And the resources, as the statement says, include networks, servers, storage, application, services. This includes a lot of different things, and it will get more clear once you see an example of a cloud provider in the demonstration section of this course. We will mostly be using or only be using Microsoft Azure during this course. However, the definition continues that the services can be rapidly provisioned and released with minimal management effort or service provider interaction. So this means that it is really quick to make new resources and also to delete the resources. And also there doesn't need to be human interaction when buying and managing the resources. It can be all done by the user in the internet portal. Finally, the definition states that the cloud model is composed of 5 essential characteristics, 3 service models and 4 deployment models. We will talk about these characteristics and the service models in the following slides. So here are the 5 characteristics of cloud computing by NIST. On-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. So the on-demand self-service means that the cloud resources are available always 24/7 self-service, which means that the customer or the user can access the cloud service portal anytime over the internet and buy, manage and delete resources there. The network access means that the resources are accessible from the internet, so the only thing that you need in order to manage the cloud services is a working internet connection and maybe a web browser software. The resource pooling means that the cloud services are internally the cloud provider is using big data centers where the resources are, and the user doesn't necessarily know where exactly his or her cloud resources like processing power resides, but for example on Microsoft Azure you know the general region where the for example the virtual machine server is. For example, North Europe can be chosen as a region, and then the computing resource, the cloud resource, is somewhere on that area, but the cloud provider is using resource pooling in order to provide the services efficiently. Rapid elasticity means that it is really efficient to scale the cloud resource up or down. This means that, for example, if you buy a virtual machine server, you can really quickly increase its processing power or increase its RAM memory or decrease it. It can be done by a couple clicks of a button in the web interface of the cloud provider. Finally, the measured service means that the usage of the cloud resource is metered by the cloud provider constantly, and the user can see how much he or she has been using the resource. And also the cloud services usually have this pay-as-you-go pricing model, which means that you are paying based on the usage. So for example, based on the processing power you are using or based on the RAM memory you are using. So this makes it really dynamic. The pricing is dynamic too in the cloud services. And yes, essentially it can be wrapped up that cloud providers offer a variety of computing services that can be bought, accessed and used over the internet. So cloud computing resources are resources that are available over the internet. Now the NIST defines 3 different cloud service models that are offered by the cloud providers. First of all, there is this software as a service which essentially mean that an application, a software application, is offered to the users over the internet. And an example of a software as a service is GitLab.com, which we are using on the practical section of this course. Also, for example, Google Docs is a software as a service. So it is a application that can be accessed with a working internet connection and browser software. Then there is this platform as a service model. And an example of that is, for example, the Microsoft Azure App Service. And platform as a service means a service where the user can use the platform to run his or her own application. So compared to the software as a service, the platform is more is at a lower level of abstraction. It is a service that allows the user to efficiently run his or her own applications, for example, web applications. So we will actually use during this course this Azure App Service in order to run our own Node.js application. Finally, there is this infrastructure as a service, which is the lowest level of cloud service models. It is a service that provides the kind of rough computing resources like processing power and RAM memory. So, for example, Azure Virtual Machines is an example of infrastructure as a service. So this, on the other hand, gives the most freedom to the user to manage the service. So in this infrastructure as a service, the user can usually select operating systems and, like I said, the processing power and RAM memory, and customize. It offers the highest level of customization, but also the highest level of maintenance. So we are not going to use these services in the context of this course, but it is useful to know that they exist. And they are the most useful in the cases where, for example, the user wants to deploy a really complicated software that cannot be done with a platform as a service solution. So I will now quickly go through some definitions. I've been using the term cloud provider before during this lecture, but it means the entity that is offering the cloud computing services over the internet. So for example, Microsoft Azure and Google Cloud, and or maybe it can be said that Microsoft, Google and Amazon are cloud providers. And they are the three biggest ones, and they have all three of these service models covered. So they offer software as a service solutions as well as platform as a service and infrastructure as a service solutions. Then consumers or users are the ones that use the cloud services offered by the provider. So here is a graphical illustration of the three different service models that we covered earlier. So on the lowest level, there is this infrastructure as a service, which essentially means that the provider is providing fundamental computing resources like processing power, storage and networks. And the use case for the consumer or the user is that he or she will use the resources and run and deploy some highly customized software, usually some kind of a complicated software system that cannot be run with a platform as a service solution. On the higher level, there is like I said, the platform as a service solution, which essentially are environments where the user or the consumer can run his or her own applications. So for example, Microsoft App Service is a platform as a service that can be used to run web software. This isn't as flexible or customizable as the infrastructure as a service, but it is more efficient to publish the software. There is less need for manual configuration in this service model. And finally, there is the software as a service, which consists of applications that run on a cloud infrastructure. So in this case, the offering is a concrete application on the internet. So for example, gitlab.com, the user goes to the access the software and uses it over the internet. Google Docs was another example. So this offers the lowest level of configuration, obviously, since it is a ready-made software solution. But there are maybe some application settings that the user can change. For example, on Google Docs you can do all kinds of configuration. But the idea is that the service itself is a complete software that the user can use for his or her needs. So here are the three biggest cloud providers. First of all, Amazon Web Services, AWS, then Google Cloud Platform, GCP, and finally Microsoft Azure. So I think Amazon Web Services is the biggest one right now, but all three of these have a really large set of services and products that can be used. During this course we will focus on the Microsoft Azure, as it can be conveniently used with the Office 365 credentials that the U students already have by the university. Also there are many other smaller providers like DigitalOcean, IBM, Alibaba Cloud, and also these ones are really big, so they are not small by any means, but the three biggest are these ones that I already mentioned, but it's good to know that there are other alternatives that might sometimes be useful. So the major cloud providers, a big reason to use them is that they do offer the widest range of selection regarding the services. And also they have really good command line tools for experienced power users. So for example, Microsoft Azure has this command line tool that can be used to basically provision the cloud resources on the command line rather than navigating on the web portal. Additionally, there are a lot of integrations between, for example, software development tools and major cloud services. Visual Studio Code is a very popular code editor, and it has a lot of extensions that integrate with, for example, Azure or Google Cloud, which make the development work even more efficient. So these are big reasons to use the major cloud providers, and usually the biggest providers also have the most cost-friendly pricing, as they have the largest amount of resources, so they can usually provide it for the most cheap price compared to smaller providers. That isn't always the case though, so I recommend to do check out all of the or some amount of different providers before making a selection on which one to use. And let's talk about Microsoft Azure a bit more in detail, since we are using it during this course. So it is one of the three big cloud providers, and like I said, all of the three big providers have a large amount of services, and Azure, for example, has over 200 different services in over 20 categories. They are mostly focusing on the infrastructure as a service and platform as a service offerings, but they do also have some software as a service offerings on their platform. Let's now talk about a little bit about web software and cloud environments. During this course, we are mainly focusing on web software and learning about DevOps practices regarding web software development. As a first point, I'd like to mention that web software, be it inside a software container or without a containerization, requires a certain type of a runtime environment. For example, a Java Spring application requires the Java runtime environment, and Node.js application requires the Node.js runtime environment. And then if the software is containerized, for example with Docker, it requires the containerd runtime environment, which Docker is using internally. So the key point is that all kinds of web software do require some kind of a runtime environment with or without containerization. And now cloud providers provide a lot of services that can be used to deploy web software, but there usually is a sort of a best option out of the services, so it does require some knowledge to choose the most suitable option inside the cloud services. For example, in Microsoft Azure, web software could be deployed with the Azure Virtual Machines service or Azure Web App service, and one of the ways is probably more efficient, and it is the Web App service when we are talking about kind of a normal web software that doesn't need any additional or complicated customization. But maybe if the software requires some uncommon dependency or something like that, then maybe a Azure Virtual Machines will be better than the Web App service. The key point to understand is that some kind of a runtime environment is needed, and in order to select from the variety of services that are present in the cloud providers, some knowledge is needed. Let's view or consider an example situation and think about what kind of a cloud service would be the most optimal in order to publish the software of the situation. So let's assume that we have a Java Spring application without any containerization, and we are using Microsoft Azure as the cloud provider. Now, as I mentioned, maybe the two most apparent ways to deploy the software on Azure would be either Azure Virtual Machines or Azure App Service. Now the Azure Virtual Machines is a infrastructure as a code service, which means that there is more manual configuration and maintenance to be done. For example, the Java runtime environment needs to be maintained and probably even installed by the consumer, and additionally any updates or added dependencies or some things like that require manual care by the consumer of the service. But when comparing to the Azure App Service, which is a platform as a service offering, there is less configuration in the app service because it allows to provide a source code of a Java. It allows to, let's say, I would say to automatize the deployment of Java software. So in the app service, you can select that you are going to deploy a Java software, and then you will provide the source code of the software to the app service, and then if nothing surprising happens, the app service is able to almost automatically deploy the software based on the source code. And now these two ways both have their strong points. The virtual machines allows for more custom configuration if it's needed, but on the other hand, the app service is a lot more efficient. So it depends on the situation, but for simple and common Java applications, the Azure App Service would be the more suitable option. Finally, I will present a new concept in regards of managing cloud software as a bonus material to this lecture. So, infrastructure as code, YAC, means to manage and overlook the cloud infrastructure of a software via certain types of definition files. So, for example, let's consider that we have a application that is using web app service for publishing, for example, a Node.js API. Then we have a PostgreSQL database on a PostgreSQL service, and maybe we have also some other cloud services like Cloud Functions in use. So one way, or the traditional way to manage these resources, would be to go to the cloud provider's graphical user interface, the web portal, and manage the resources from there. Also, the CLI command line interface is available on Azure to manage the cloud resources. But now this infrastructure as code concept means that it is a new way to manage the cloud resources. Basically, we are making these YML, or I'm not sure it's YML, but these sort of certain types of files, kind of like a Docker file. So it has a special syntax, and in the file it is defined what cloud services are to be used with the application. So for example, the file would include in this case the Azure Web App Service, and then the PostgreSQL service and the Functions service, and the idea is that the file can be version controlled and it can be viewed by all of the developers, and then the developers can know basically what kind of cloud resources are in use without accessing the cloud platform. And also, if some changes needs to be made to the cloud resources, the change can be made to the definition file rather than navigating the graphical user interface. So it is a more lightweight way to manage the cloud resources, and basically it is a way to sort of kind of standardize the provisioning of the cloud resources, and Terraform is one example of this kind of a service. So Terraform has a special syntax like Docker and Dockerfile has. The syntax can be used to kind of describe a cloud environment, for example on Azure or Google Cloud or AWS. It also supports many other cloud providers, I think. So all in all, this infrastructure as code can be seen as an abstraction layer above the cloud services. So it is a kind of a layer above the manual navigation of the cloud resources. It is a way to structure and define the resources by the special files. So it is a really interesting concept, and I recommend to check, for example, the Terraform out if you are interested in it. Finally, here is the reference to the definition of cloud computing. Also, the cloud services websites have been used when producing this lecture set. And thanks for your time, and don't hesitate to contact the core staff in case you have any questions.